You ready for a deep dive into the world of math?
Oh, yeah.
Today,
Always ready for that.
we're tackling a conjecture that had everyone fooled,
Uh-oh.
even mathematicians.
Oh, right.
It's called the bunk bed conjecture. And for years, it seemed so obvious that nobody even bothered to prove it. But guess what?
What?
It turned out to be totally wrong.
It really highlights how even in math, our intuition can sometimes lead us astray.
Exactly.
Yeah.
And that's what we're going to unpack today.
Cool.
We'll explore how this seemingly simple idea turned out to be way more complicated than anyone expected,
Right.
and what that tells us about the nature of math itself.
I'm excited.
But first, let's make sure we're all on the same page.
Okay.
What exactly is a mathematical conjecture anyway?
Well, it's kind of like a scientific hypothesis.
Okay.
It's an idea that seems likely to be true based on observations or patterns,
Yeah.
but it hasn't been formally proven.
Gotcha.
Think of it as a mathematical hunch that needs to be put to the test.
Okay, so this bunk bed conjecture was one of those hunches.
It was.
And it seemed so obvious that everyone just assumed it was true.
Right.
But as it turns out, there was a twist.
A twist.
So tell me, what does this bunk bed conjecture actually say?
All right. Imagine a bunch of dots connected by lines.
Okay.
We call this a graph in math.
Okay.
Think of it like a map of a city, where the dots are buildings and the lines are streets.
Okay.
Now picture making a copy of that map
Okay.
and stacking it right on top of the original,
Yeah.
you guessed it, a bunk bed.
A bunk bed. I get it.
We then connect some of the corresponding dots
Right?
on the top and bottom maps with vertical lines,
Yeah.
our bunk bed posts.
Okay, got it.
Mm-hmm.
So 2 maps stacked like bunk beds
Yeah.
with some posts connecting them.
Yeah.
What's next?
Now we introduce some randomness
Okay.
for each line on both the top and bottom maps.
Yeah.
We flip a coin.
Okay.
Heads, we erase the line.
Uh-huh.
Tails, we keep it. So both bunks of our map start to look a bit different,
Gotcha.
with some connections randomly removed.
So we've essentially created these random mazes on each level of the bunk bed.
Exactly.
What's the conjecture about?
The conjecture states that if you pick any 2 dots on the bottom bunk,
Okay.
the chances of finding a path between them
Yeah.
is always higher than or equal to the chances of finding a path between one of those dots on the bottom and its corresponding dot on the top bunk.
Wait, so it's saying that it's always easier to stay on the same level of the bunk bed
Yeah.
than to have to climb up to the top?
Yeah.
That does seem pretty intuitive.
Right.
Why would adding that extra jump ever make it easier to find a path?
That's exactly why this conjecture seems so obvious to everyone.
But it wasn't true.
Nope.
So who was the brave soul who dared to question this seemingly unshakable mathematical truth?
That would be Igor Pack,
Okay.
a mathematician known for his healthy skepticism,
Okay.
especially when it comes to long-standing conjectures.
Mm-hmm.
He just had this gut feeling that the bunk bed conjecture was too broad.
Interesting.
He wondered, could it really hold true for every possible graph, no matter how complex?
Mm.
And that seed of doubt he planted turned out to be pretty important.
So Peck thinks there's something fishy going on.
He did.
What happens next?
What?
Does he try to debunk it all by himself?
Well, he had some help.
Okay.
He recruited 2 of his graduate students,
Right?
Nikita Gladkov and Alexander Zimin,
Got it.
to help him find a counterexample.
Uh-huh.
Basically, a single graph that would break the bunk bed rule.
And did they find it?
Their search for this counterexample is actually where things start to get really interesting.
Okay.
You see, Gladkov and Zimin were roommates at the time.
Uh-huh.
And get this, they had a real bunk bed in their dorm room.
Wait, so you're telling me they were tackling this mathematical mystery while literally living on a bunk bed?
I know, right?
That's amazing.
It's perfect.
Yeah.
They actually started by trying to manually check every possible graph to see if they could find one that broke the rule.
But there are like a zillion different graphs, right?
Oh, yeah.
I mean, even with a bunk bed for inspiration,
Yeah,
that sounds like a pretty daunting task.
you're absolutely right.
Yeah.
The number of possible graphs explodes incredibly quickly
Right.
as they get larger. So checking every single one by hand was just impossible.
So what did they do?
Well,
Give up and go back to their non-mathematical lives? I feel like these guys wouldn't give up that easily.
Oh, they didn't give up.
They didn't.
They decided to get some help from a more modern tool, artificial intelligence.
AI and math.
Yep.
Now that's an interesting combination.
It is.
How did they use AI to try and debunk the bunk bed conjecture?
They trained a neural network,
Okay.
a type of AI,
Uh-huh.
to generate graphs that were likely to have paths that preferred going up to the top bunk.
Interesting.
In other words, graphs that might break the bunk bed rule.
So they were basically using AI to help them narrow down their search for this elusive counterexample?
Exactly.
Okay.
It's a pretty clever approach.
Yeah.
And it actually did yield some interesting results.
Did it?
The neural network managed to find some graphs where the probability of a bottom bunk path was only slightly higher than a top bunk path. But there was a catch.
So they were getting close.
Yeah.
Like, they had the AI pointing them in the right direction.
Right.
But they still couldn't be totally sure they'd found a graph that definitively broke the rule?
That's exactly it.
Okay.
They were over 99.99% sure in some cases.
Wow.
Which in most situations would be a slam dunk.
Yeah.
But math is all about absolute certainty.
Right.
That tiny sliver of doubt,
Uh-huh.
that 0.01% chance they were wrong,
Right.
was still a huge gap.
So it's kind of like those online quizzes that tell you what kind of pizza topping you are.
Okay. Yeah.
99% sure you're pepperoni,
Right.
but there's still that 1% chance you're actually pineapple.
Exactly.
Mathematicians don't mess around with maybes.
Nope. They need proof. And even if they did find a definitive counterexample with the neural network,
Yeah.
there was another hurdle.
What's that?
The math community might not have accepted a proof that relied on AI. Because AI, by its very nature, is probabilistic.
Uh-huh.
It deals in likelihoods, not absolutes.
That makes sense.
Yeah.
It's kind of like trying to convince a judge with evidence from a psychic instead of hard facts.
Right, exactly.
So what did they do? Throw in the towel and say, okay, maybe the bunk bed conjecture is true after all.
Well, they didn't give up entirely,
Okay.
but they did put the AI approach on hold for a bit
Right.
and tried a different tactic.
Okay.
They spent months trying to come up with a purely theoretical argument,
Yeah.
one that didn't rely on any computer calculations at all.
It's just like pure math.
Pure math, yeah.
Okay.
They were so close to cracking the code, but it felt like they were missing one crucial piece of the puzzle.
Ooh, this is where it gets really suspenseful.
Did
they ever find that missing piece?
They did.
I did.
And it came from a pretty unexpected place.
Where?
Another mathematician named Lawrence Hollum was working on a related problem.
Okay.
But instead of using regular graphs, he was using something called hypergraphs.
Hypergraphs.
The hypergraphs are a bit more abstract.
Okay.
But the important thing is that Hollum managed to find a counterexample to a version of the bunk bed conjecture
Okay.
that applied to these hypergraphs.
Okay, so a breakthrough with hypergraphs.
Yeah.
But we still need to debunk the conjecture for regular graphs, right?
Right.
Was Hollum's work even helpful?
It was more helpful than they could have imagined.
Really?
Gladkoff read Hollum's paper
Uh-huh.
and had a light bulb moment.
Oh.
He realized they might be able to translate Hollum's hypergraph counterexample
Uh-huh.
into a normal graph that would also break the bunk bed rule.
Hold on. Translate a hypergraph into a regular graph.
Yeah.
Isn't that like trying to turn a Shakespearean sonnet into a grocery list? Is that even possible?
It's not easy, that's for sure. Right.
But luckily for Gladkoff and Zimin, they'd actually been thinking about this kind of translation problem a while back.
Oh, really?
And get this, they were on their way to a Red Hot Chili Peppers concert when inspiration struck.
Wait, hold up. They were brainstorming complex mathematical problems at a rock concert.
I know, right?
These guys are hardcore.
They are.
So they had the tools they needed.
They did.
Did they manage to make the translation work?
Yeah.
Did Hollum's hypergraph breakthrough lead to a regular graph counterexample?
It did.
Wow.
They took Hollum's hypergraph and using the techniques they developed earlier, probably while rocking out to the Red Hot Chili Peppers, they were able to translate it into a massive, insanely complex graph.
Okay.
I'm talking 7,222 dots and 14,422 lines.
Wow, that's one heck of a graph.
It is.
They must have needed a supercomputer just to draw the darn thing.
Pretty much. But did it actually violate the conjecture?
It absolutely did.
It did.
Using the theoretical arguments they developed earlier, they proved that this monster of a graph they'd created completely shattered the bunk bed conjecture.
Wow.
Remember how the conjecture said it's always more likely to find a path on the bottom bunk?
Yeah, that whole staying on the same level is easier thing.
Right.
Is burned into my brain at this point.
Well, in this giant graph they constructed, the odds were actually slipped.
What?
Finding a path that went up to the top bunk
Yeah.
was over 1,000,000% more likely than finding a path on the bottom.
Seriously?
It was a tiny difference in terms of probabilities, but it was enough to completely demolish the conjecture.
Whoa, that is a serious plot twist.
It is.
So after years of work, they finally found their elusive counterexample.
They did.
They must have been ecstatic.
Oh, absolutely.
Yeah.
It was a major win, not just for them, but for the entire mathematical community. It proved that even in math, which we often think of as a field of absolutes,
right,
there's always room for surprise and discovery.
Okay, so they proved the bunk bed conjecture wrong.
They did.
Case closed, right?
Pretty much.
But I have to ask, so what?
Yeah, good question.
Does this discovery actually change anything outside the world of abstract mathematics?
You know, that's a great question.
Yeah.
And it highlights why this whole seemingly esoteric math problem is actually pretty important.
Okay.
Remember how we talked about how the bunk bed conjecture was inspired by a physics concept? About how liquids move through porous materials?
Right, yeah.
Well, physicists still think that underlying principle is true.
Okay.
But now, thanks to Pack, Gladkov, and Zeman, they need to find a new way to prove it. They can't rely on the bunk bed conjecture anymore.
So it's back to the drawing board for the physicists.
It is.
But what about math itself? Did disproving this conjecture change how mathematicians do their work?
It definitely reinforced the importance of questioning assumptions, even those that seem super obvious. And it also ignited a really interesting debate about the role of technology in mathematics.
Right.
Remember how Pack and his students initially used AI to try and find that counterexample?
Right, that whole AI versus pure math thing.
Yeah.
It seems like it's a pretty hot topic.
It is.
Yeah.
Some mathematicians believe that we should embrace AI and other computational tools to help us solve problems and even generate proofs. But others worry that relying on AI could lead to proofs that aren't truly rigorous or that we don't fully understand.
So it's kind of like a philosophical question about the nature of proof itself.
It is.
What does it really mean to prove something in math?
Right.
Can we trust a computer to do it for us? Or do we need that human element of understanding and insight?
Exactly.
Yeah.
It's a question that mathematicians are still grappling with today. And the answer could have a big impact on the future of the field.
It could. It's amazing to think that this one seemingly simple conjecture has opened up so many complex questions.
Yeah.
It's like those Russian nesting balls where you open one up and there's another one inside and another one inside that.
It really shows how interconnected math is with other fields like physics and even with philosophical questions about the nature of knowledge itself.
Okay, let's take a step back and recap what we've learned today.
Okay.
We started with this idea that seemed so obvious.
Right.
It's easier to stay on the bottom bunk of a graph than to climb up to the top.
Yeah, the bunk bed.
Then we met Igor Pack, the ultimate mathematical skeptic who dared to question this obvious truth. He and his students embarked on this incredible journey battling computational limits, teaming up with AI, and finally discovering a massive complex graph that completely shattered the bunk bed conjecture.
It was a big discovery.
It was.
Yeah.
And in the process of debunking this conjecture, they've sparked a fascinating debate about the role of AI in math and what it really means to prove something.
Yeah, for sure.
What's really interesting is that the bunk bed conjecture itself, even though it turned out to be false, has been incredibly valuable.
I think so, too.
It's pushed mathematicians to think more deeply about fundamental questions.
Yeah.
And to explore new approaches to solving problems.
Definitely.
So what does this all mean for you, our listener?
Right.
Why should you care about a bunch of mathematicians arguing about bunk beds and graphs?
Good question.
Well, I think there's a bigger takeaway here about the importance of curiosity and critical thinking.
I agree.
Don't be afraid to question assumptions.
Yeah.
Even those that seem totally self-evident.
If we connect this back to everyday life, it's a reminder that our intuition, while often helpful, can sometimes lead us astray. In a world overflowing with information and misinformation, it's more crucial than ever to be skeptical, to dig deeper and to look for evidence, even when it challenges our preconceived notions.
You know, it makes you wonder what other obvious truths are out there just waiting to be debunked.
Yeah.
What other bunk bed conjectures are lurking in the shadows, ready to surprise us?
That's the beauty of knowledge. It's a never-ending journey.
That's true.
There's always more to learn, more to question, and more to discover.
Definitely.
Who knows what seemingly unshakable truth will be toppled next?
That's a great note to end on.
I think so, too.
Thanks for joining us for this deep dive into the world of bunk beds, graphs, and the surprising fallibility of mathematical certainty.
Yeah, thanks for having me.
Until next time, keep those minds curious and those questions coming up.